Good morning all, I'm Luisa Moisio. I'm the Director of Research and Development at the Rail Safety and Standards Board in the UK. I am delighted and it's a great privilege to be giving this keynote speech at today's celebration of the 27th anniversary of the Korean Railroad Research Institute. Before diving into the topic, safety in a digital railway, I thought it useful to provide a quick introduction on how research fits in within the wider RSSB remit and work. At RSSB, research underpins our work in safety analysis and standardization, ensuring that these evolve to drive improvements and enable the take-up of new technology. The railway faces many challenges that are not in the gift of a single organization to solve. The challenge that caught RSSB set up and very much the RSSB program started approximately 20 years ago was safety. And today burning imperatives for the rail network in Great Britain are delivering more value for money and improving service reliability. To tackle these challenges, including maintaining and as far as reasonably practicable improving safety, the industry needs to change. Needs to adopt new technologies, particularly digital technologies. These inevitably introduce new unknown risk, which in a safety critical industry like rail is often a barrier to change. Some might perceive standardization and safety to be in tension, if not an obstacle to innovation. But actually they can be very important and very powerful enablers. The RSSB research program exists to ensure that this is the case, so that safety analysis and standardization inform and support the new opportunities and changing needs of the railway. How safety and standardization need to evolve in a digital railway is very much the perspective I will be offering in the rest of the talk. The application of digital technology in rail is here to stay and to grow. Indeed, many railway transformational programs around the world have digital as a more or less explicit reference in their name, in their title. But what does a digital railway look like? A succinct description might include reference to digital signaling, providing real-time information about the network and the location of trains. It may also mention the elimination of signals by the trackside and the introduction of moving blocks to increase line capacity. It would include references to real-time advice and reliable advice on the best options to get services back to normal and to recover more quickly in an event of disruption. And of course, it would also mention the provision of better information to customers, freight and passengers, information tailored to their needs. So, a digital railway is clearly made up of quite a number of different and distinct aspects. They are all relevant to make the railway safer and better. And they also raise some interesting wider safety and standardization considerations. So let's look at each of them in turn. Many paper-based processes have migrated into digital systems. This has been a great step for productivity, a great step for error reduction. Now, in this context, RSSB has considered over the years the use of mobile devices. For a long time, their use by frontline staff has been banned or severely restricted as a source of distraction, but they continue to evolve and also they have become the essential backbone of digital working practices. So where does this leave us when it comes to the management of distraction and overload that such devices can cause? There is clearly no easy, no silver bullet type answer, but this ongoing work shows the need for awareness and for proactive management of the unintended consequences of digital tools. RSSB is also looking at the digitalization of standards and operational rules. The first step made by many, including RSSB, has been to make this material accessible via smart digital interfaces and apps. But this is very much the beginning, the start of the journey. And the opportunity and challenge on the horizon is how to make standards and rules machine readable, so that, for example, compliance with them can be checked with less effort and more accurately. Only if standards and operational rules are machine readable, they can be integrated into digital models, such as railway digital twins, of which there is much talk about. Models and twins are all about data, and the technology available to capture, to transmit, to process asset data continues to improve. It has already helped to improve safety by reducing and removing, in some cases, the exposure of maintenance workers to safety risk during inspections. It has also allowed better monitoring of assets that have traditionally been very hard to reach. So what are the challenges when it comes to introducing and then using more and more remote condition monitoring and moving it into preventive maintenance? First, I would mention the calibration of algorithms to avoid false positive. Particularly at the start of their introduction, this is something that we have seen and needs to be addressed. There is also, and very much related, a big challenge in determining what level of reliability and validation is needed to justify the decision to move away from manual inspection. At present, we often end up continuing to do both for a very long time, continuing to do both manual and automatic condition monitoring, which is not delivering the full benefits of the technology. When it comes to rail assets, monitoring from lots and lots of data and moving from such a vast amount of data to validated and actionable insight needs more than big data and AI techniques. These need to be combined with sound scientific understanding of how assets are expected to behave. And it is worth noting that in some cases such understanding has not been tested to the limit. For example, information of failure trigger points is limited, particularly when it comes to, for example, extreme weather that climate change is making more frequent. And last but not least, the challenge of prioritizing the deployment and exploitation of sensors. Sensors continue to evolve, continue to be a great technology to use, but actually we are faced with potentially a very vast network to be fitted with sensors, and also the challenge of retrofitting sensors into existing and in some cases older rolling stock. So how to prioritize, how to do it is very much the challenge. When it comes to the operational side, at present the railway uses only the tip of the iceberg of the operational data that exists. Data from trains, data on signal status, recorded communications between staff, and many other pieces of everyday train service information could be extremely valuable in monitoring and improving how we run services if used systematically. RSSB has been looking at how train data combined with other data sources can improve train driving, with benefits to both safety and reliability. And as always, success is not only about the tech and the algorithms. Of course they are needed, of course their quality is important, but success, it's also and very much about how these are rolled out in a fair culture that promotes ongoing improvements. In the same spirit, we have just started to look at the use of natural language processing to monitor and drive improvements in safety-critical communications. For many, a digital railway is all about the next generation of signaling and train controls, particularly about the automation of train controls. It's a huge topic, and I cannot even start to do it justice. Amongst the biggest benefits of digital train control technologies are the removal of human errors and the delivery of very high level of line capacity. At the same time, this is such a paradigm shift in safety terms that it brings about a series of new challenges, such as the need to manage the risk of undetected and/or not yet patched vulnerabilities, the need to determine appropriate software upgrades, the need to validate and approve what in many cases are black box type solutions, where it is not quite clear how the answer that is applied for train movements is derived from. And last but not least, the management of the graded working, which brings the challenge of skill retentions to another level from what the railway has experienced to date. Of course, again, digital technologies are there to help with the latter challenge. Virtual reality, augmented reality can help with having staff experiencing routinely rare occurrences, but their use is still very limited and their current cost not indifferent. Digital opportunities have driven and continue to drive significant changes on how we interact with passengers. The obvious one is the transformation that these technologies can make to how we keep passengers up to date and promptly informed. But there are a lot less obvious ones that can play a very important role in safety management. For example, during COVID, there has been a significant increase in the use of passengers' mobile phone to determine their location and use this information to manage passengers' number on train and passengers' flow at stations. AI techniques can be used to bridge information from social media, and in case of accidents, these can be very helpful in managing the response. And we have started to see the application of virtual reality for educational and rail familiarization purposes. For example, they're used to help passengers navigate stations, or they're used to teach children about the danger of trespassing on the line in a much more engaging and memorable way than just a video or a talk. Now, a few final thoughts on the cross-cutting challenges in moving towards a digital railway. Firstly, the need for new approaches when it comes to testing and validation of these technologies. There is a lot of work to be done for validation and testing to be robust as well as efficient, in particular to cover the need to ensure compatibility with existing systems. There is also the need to ensure that the structure of supply chain and the associated contractual frameworks evolve to be fit for managing the changes in data and software ownership that digital technology brings about. We need to have ambitious goals and be successful in making the case for a high level of initial investment, which are required. Now, it is important to note that in constrained public finances, with challenges around access to both private and public investment, Some cases for investment are even harder than others, particularly when we need to invest in what I would call enabling technology. For example, the replacement of old back office systems that have significant ramification for the running of the network. There is an obvious challenge in making the case for such enabling investment, but this is core in achieving the benefits of a digital railway and be able to plug on this enabling technology some of the tech solution I've been talking about. And last but not least, the need to raise the skills of railway staff so that they feel able and empowered in this changing railway. Thank you very much. Thank you very much for your time. And I would like to take this opportunity to wish you all at KRRI every success in your endeavors.